Okay, welcome everybody. This is the oral presentation for the first experiment in Intro to Chemistry. My name is David Ford, and here are all of our lab materials we're going to use for the experiment. We have rubbing alcohol, graduated cylinder, dish soap, sugar, all of our cups, honey, food coloring, toothpick, paper clip, tweezers, a glass, a wooden cube, pencil, ruler, and vegetable oil. My hypothesis for this lab, I think the density of water is going to be 1 gram per cubic centimeter because I feel that water is probably used as a standard. I think as far as the layering, I think the rubbing alcohol will be on top, then the water, then the oil, then the soap, and then the honey. And for the rainbow cup, I think the blue will be on the bottom because it'll be the most dense, then green, then yellow, then red on top being the least dense because it'll have the least concentration of sugar in it. So, alright, let's get started. This is the first part of the lab, the basic calculations. So the first part, record the number of inches and centimeters on a ruler. There's 12 inches on a standard ruler and 30.5 centimeters. The number of centimeters per inch, take 30.5 and divide it by 12, so you have 2.54 centimeters per inch. Same thing with the millimeters. That means there's going to be 350 millimeters on a ruler. Divided by 12 inches is 29.16 millimeters per inch. Alright, next we're going to take the pencil and measure it. This pencil is exactly 15 centimeters. Alright. Next, we're taking one of our blocks. Going to take a weight on it. Alright, the block is 2 grams. Length of each side of the block. It's a cube, so each side is going to be the same, which is 1.5 centimeters. So, we want to find the density of that block. To do that, we divide the mass of the object by the volume. So the mass was 2 grams. Oh, we have to find volume first though. Volume will be your length times width, times your other length, times height. So 1.5 centimeters cubed is 3.375 cubic centimeters. So to find the volume, we're going to take 2 grams and divide it by 3.375 centimeters cubed. Our answer is 0.592 grams per centimeter cubed, which, to write that correctly, is 5.9 times 10 to the negative first grams per centimeter cubed. Alright. Next, I have to measure the width of the textbook. So, we're given the number of pages, which was 7.4 times 10 to the negative second, or 10 to the second, which would make it 740 pages. I'm going to take a measurement on it with the ruler. The most precise that I could come up with was 2.7 centimeters. So to find the width of each page, we take the number, or the width, which is 2.7 centimeters, and divide it by the total number of pages, which is 740. The answer I got is 0.00364869, which, when you write it correctly, is each page is 3.65 times 10 to the negative third centimeters. Okay. So next we want to weigh our graduated cylinder. which is 41 grams. We're going to fill it with 100 milliliters of tap water. And reweigh. Okay, well, it should be 141 grams, but, so which makes, we're trying to find the density of water, of tap water. So we take 100 grams, divide it by the volume, which is 100 milliliters, which gives us 1 gram per milliliter for the density of water. Part 2 of the lab, oil and water. First we're going to pour 60 milliliters of water into the glass. Color it. Okay, add 60 milliliters of oil to it. Okay, just like everybody knows, oil and water don't mix. When you stir it, after you wait, they separate out. I had to look up the reason why this is, and from what I understand, what I found is that water molecules are polar in nature, so they attract other water molecules, and oil is not polar, so the water molecules are trying to attract themselves while pushing away from the oil molecules. Part 3, the layered liquid part, I have honey, dish soap, this is water, vegetable oil, and in the third cup we have rubbing alcohol. So we're going to layer them and see what happens. We divide it into 6. So there's dish soap. See, it's just still separated, the honey and the dish soap. Now this is just water with food coloring in it. So, right now we have the honey, the dish soap, and the water. Next we're going to add vegetable oil. It's still separated. So last we have the rubbing alcohol. Okay, it's still separated. So a couple properties of each, just that I can see, I guess. The honey is definitely the heaviest out of all of them, weight-wise. And I don't know, it's sticky. I don't know if that has anything to do with it or not. The soap, a little bit less than honey, a little bit thicker than water still, obviously. Let's see what's next. The water in the middle. And then the oil sits on top, which is no surprise because of the last experiment we did. We showed that. And I guess it must be lighter to be on top. And then the rubbing alcohol is definitely the thinnest out of all of them. Okay. Next we have a paper clip and toothpick. I weighed each one, but each was less than a gram, and my scale couldn't pick it up, so I don't know how much they weigh. So the paper clip, I will bet, goes through the rubbing alcohol and stops. It probably goes through the oil and stops at the soap, is what I think. Okay. You can't see it, but it did. It stopped at the soap. So it's right here. The toothpick, I think, is going to go through the rubbing alcohol but float above the oil. And I was wrong. It stayed on top. Okay, so next I'm going to stir all these up, and then we'll let it sit for a minute and check back in and see just exactly what it does. Okay, so we'll let this sit, and in a couple minutes, go ahead and take another look and see what happens. Okay, so for part 4 of our experiment, the last part is the rainbow cup. So with each of these, there's 45 milliliters of water in each of these. In cup 1, there's 15 grams of sugar. Cup 2, there's 30 grams of sugar. Cup 3, there's 45. In cup 4, there is 60 grams of sugar. So we're going to try and add these all together and see what happens. The cup 4 with the 60 grams of sugar is definitely very syrupy. Okay, so they stayed separated for the most part. It's kind of hard to see, but alright. Now this one has 30 grams of sugar. Definitely not nearly as syrupy, but definitely thicker than water. Right. And the last one with 15 grams of sugar. This one's definitely close to just being water. So it's hard to tell, but you can, the light's not very good, but you can see that there is a difference in them. It's not nearly as defined as the last experiment. It more just goes from darker to lighter. I think they blend a little bit more than the other ones did. Because I think that's actually because it is the same substance throughout. I think it's just different densities of it because of the amount of sugar in it. So, all right, now. What affects the density of each solution? Obviously, the concentration of sugar does. Again, I feel that's why it's not so clearly defined line, because it is the same substance throughout, but just different densities. Which I think, when I stir them up, it's all going to become one mixture. And so I don't believe there's going to be any lines at all, any definition. Which it has. Now it's all just the same throughout, with coloring in it. Alright, so that concludes the first experiment, the measurement and the metric system. Okay, and we're back to the experiment 3. This is the cup. It's been sitting for about 15 minutes now. It looks like the honey went back to the bottom. It looks like the soap and water have mixed in here. And then the oil is on top. And then on the very top is a thin layer of the rubbing alcohol. Not nearly as much. I think the rubbing alcohol and the oil somehow have blended a little bit. And the soap and water have blended throughout, it looks like. I'm not surprised. Obviously, it's soap and water. And then I also think that the honey blended into the soap and water also dissolved. The sugar in it dissolved. And this is just what didn't get stirred up. So, that's that.